Hey everybody, this is Larry. This is day 6 of the Leetcode Day Challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about today's farm. Today this is a rest day for me. I really need to ramp up with my training, but just like everything about my upper body is sore. My lower body was okay actually. I guess I put it into good work. So yeah, so that's good. So maybe I need to do this class more often because like it beats me up in a good way. But yeah, all right, let's take a look at today's problem. We have 2434 using a robot to print the lexicographically smallest string. All right, I'm not gonna go over things that I'm not gonna go over lexicographically just because we did that yesterday, right? So hopefully that makes sense. But the short recap is that whenever we need the lexicographically smallest thing, the way that I think about it or visualize it a little bit easier, I think it's more relatable, is instead of letters, we use numbers, right? Because if you have two strings of the same number, like, whatever, and maybe the way that one is like something like this, like if you look at these two, you would never say, oh, this is a bigger number. This is a bigger number, or this is a bigger number because it has more nines or whatever, right? You just go one digit by one digit. It's the same thing for strings. So then what I mean by that is that if you have like one A, it doesn't matter if they're or Z. The other one, you have an A in the beginning, it's always going to be earlier. That's the TLDR. I think sometimes I myself get confused, and I try to use that visualization to help myself figure out how to get the shortest mean, right? Okay, so let's take a look. You're given a string S and a robot that currently holds empty string T. Apply one of the following operations until S and T are both empty. Remove the first character of a string S and give it to the robot. Okay, it would append this character to the string T. Remove the last character of string T and give it to the robot. The robot will write this character on paper. Okay. Return the lexicographically small string that can be written on paper. So what does this mean? Okay, that's so you have a string Z, and then it would take the first character and then give it to the robot. So this is S and this is T. Oh no, this is just, I don't know where that is S, and this is T. All right, and then we do it again, maybe, if we want to, or we could remove T, right? I think greedy makes sense in this one, right? In the sense that, okay, well, I mean, it's an easy decision of like, okay, do we only have two moves to do at this point, and we either print Z, maybe we want to, maybe we don't, or there's a better character than S, which in this case there is, right? Because there's an A in here, and because there's an A in here, we know that if we just keep on doing the first option, we'll eventually get an A, and that A will eventually get to the T. Like, I mean, in this case, we have ZZA, right? But even if there are like a lot more Zs, here when we get the first Z, we know that there's an A coming, right? So that's what I'm trying to say. Even though it doesn't have to be the last character, but we know that there's going to be A and in the thing, and because of that, then we know that we can remove this and put it here, and then it doesn't matter. Like what we said about lexicographically smallest, right? If we get an A in the beginning, pretty much nothing matters, right? And then you could, and the thing with this thing is that also, it's kind of like like if you have two A's, there's no tiebreaker, in the sense that you want both of them, right? So then now, yeah, and then now you remove all the A's, and then what happens? And then now, I guess you just go, well, is there a B in S? Is there a C in S? ... And then you just remove from T whenever the beginning of T is or the end of T in this case. Actually, the end of T is the smallest character out on top of S. Then we move from T, right? I think that sounds right? So this is greedy in that core, in that because here we try to fill this character in paper one character at a time by lexicographically smallest idea. This is going to be greedy in that, because going back one step, I think I jumped ahead one step in my mind that I didn't explain, which is that we want to go, okay, is it possible to get an A? And maybe in that way, it's possible to get an A if either it is the last character in T or it is in S. If it's in S, then we just keep on going until, you know, we get an A. But then even if we get the first A, we ask again for the second character, is there possible to get an A? And that's basically the idea. I think that should be pretty good, right? So okay, so do keep track, and then next part is about doing it in a fast way. N is 10 to the 5th, so you know, anything n squared, no bueno, right? But what we can do is try to answer these queries as fast as we can, right? So we can start with the structure real quick, right? So maybe we have the answer. We go, okay, and keeping in mind that once, and it really has to be the beginning, right? I think I missed one case to discuss, which is that if, you know, maybe, well, first of all, if you have S and T, A can never be hit T, right? Because whenever you get an A, it just goes here. But let's say you have a B, let's say maybe you have a, you know, BBZZA or something like that, and then now you have BBZZ, oops, ZZ, and then now we got rid of the A, right? And then now, even if you have C's, even though there are B's and T, we would never take them because, you know, because if you try to get one of these B's, it'll go ZZB or something like that. And here is a C. So no matter what you do, having the C will be more optimal in a greedy kind of way, right? But C will come before the Z no matter what. So okay, so given that aside, we can go, okay, well, the current best character is A, and that's what we're gonna look for, right? And then now we have for is it a for loop or a while loop? Maybe a while loop is fine, right? So we'll write true for now as a placeholder. We can make a condition later. But basically what we want to do now is go, yeah, is best in S, right? Yeah, is best in S. Or the last character in T, right? I changed this to or because it doesn't matter, right? In the sense that, okay, let's say there's so many examples, and that's why I'm like, it's a lot to think through, but the idea is still going to be greedy, right? But the thing is that, okay, let's say we just finished getting the A's into the printing, and then now we have, you know, by definition, there's no more A's, and then you have like C, 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 B, and then, I don't know, Z, 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 B, right? In this case, you'll just take the B here. But let's say, you know, by luck, maybe the initial string was something like Z, 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 B, A, B. So then now you get the B, you get the A, and then now you have B on the S and B on the T on the last character. Well, then which one do you choose? All right? I was going to say it doesn't matter, but I'm wrong on this one. I think you always want the T, because otherwise, by definition, the characters that you skip are not B, and by definition, the characters that you skip on the S that you would have put on the T are after B, right? Because if they're B, then they're just B. If they're A, you already processed them. So it has to be C or later, and as a result, you always want to get T, because otherwise, let's say there is a C, you always want this B from T, right? Yeah, because if you don't get it from T, then you would remove the C, put it here, and then get this B, but then now you cannot get back at this B, right? So, okay. And if they're the same, then it doesn't matter, but you still maybe say typebreak of the T just to keep it easier to code, right? Or fewer edge cases. Okay, so that means that, okay, yeah, let's just start with S is equal to, oh, this is the S. Let's just say list of S. No, is it removed from the beginning or the end? Okay, yeah. So let's just say deck, right? convert to a deck, so then we can remove. And then T, let's also, well, this remove at the end, so let's say it's a stack, right? And then, yeah, we go if length of T is equal to or greater than 0, and T of last T is equal to best, then we want to pop answer dot append best, and then we continue, right? Otherwise, if length of answer, or not answer, sorry, length of S is greater than 0 and T of 0 is equal to best, then, oh sorry, S of 0. Oh man, I'm really bad. Right? Then here S of pop left, answer dot append best, and then continue. Otherwise, so okay, so otherwise, well, there's only one action to do, right? We move, well, okay. Otherwise, is best in S? Is best in S, right? So you would write something like is best in S, right? And then if it is in best, then now we just keep on going. We go, okay, while length of S is greater than 0 and S of 0 not equal to best, then S of pop left, just C is equal to this, because we have to put it into T. And then that's it, right? Yeah. And then now the invariant ends if either, I mean, we know that best is in S, so that means that this invariant will end. So actually we don't even need this, because this will never be true, because eventually S of 0 is going to be equal to best, and that's the invariant after this loop. Then now we can say answer S dot pop left, which is going to be the best, and then answer dot append best, and then continue, right? And then else, best is not in S, so then now we just want to say increment best, right? Meaning that, okay, we try to look for A. Maybe best is not quite the way, but it's too late, I guess. Too lazy to change it. Like if there's no more A's in the top, then we just go to B's, and then C's, and then D's, and then so forth, right? So this is kind of like this, but it's not quite, because it's a string. So what you want is that if best is equal to Z, then we just break. Otherwise, because we want to increment, right? Otherwise, best is equal to the order of itself plus 1, and then turn back into a char, right? And that's it. And then the other case is now S still has characters, right? Or is it S or T? No. Because by definition, T will have more characters, because S should go through all the best should go through all the characters. I mean, this should go through all the characters if best is in T. Otherwise, if this goes through, then is that true? Yeah, because if we go A and then you remove as much as it can, gets to the first A. Because you think of it, first A, B, and then basically the last character would be the last time this is true, right? And the last character in S where this is the last time and this is true. So then once that gets removed, then S of 0 is going, or length of S is going to be 0, and then that means that this is false, and that means that we're going to increment, and then if this is Z, or keep on incrementing until best is Z, and then it breaks out the while loop. But then now T has characters, so while length of T is greater than 0, we do pop answer dot append that, and then at the end we just return to do that join answer, right? So okay, so what's wrong with this? I mean, it looks okay. We'll check it out to see what works. It looks okay, but the thing is that this is too slow, right? I don't know. Leetcode sometimes is weird, so maybe it's fast enough. It shouldn't be. And the reason is because this best in S, it does a loop on a queue, right? And that is O of n. And if you're not careful, this is n squared. Not gonna lie, I didn't know this. I'm trying to figure out what's the best way to kind of explain my thought process. So this time I wrote out the code for actually an incorrect thing. Not that it's incorrect, just not fast enough, right? For a time limit thing. And it is this thing. And because we do want to optimize this, but we still want to answer this question. And so what's the best way to do that? For me, and I honestly did come up with this as soon as I saw it. I just kind of put it back a little bit. Let me know if this is a little bit more effective in understanding. But yeah, now basically now we have this code. We want to answer this in O of 1 or log n, something fast. And the way to do that is, of course, just a frequency table, right? So basically we just go, okay, well, f is equal to collections dot counter of s, right? And then now it's just bookkeeping, right? We're keeping track of s. So whenever we pop left, we in this case, this is removing just the best. So so then f of best, right? And here, I guess it doesn't do it. But anytime we remove from s, so this one, right? So that means that f of whatever we just popped, -1, and here as well, just f of c, right? Yeah, I mean, I guess this is also best. I think let's keep it that way, because by default, I mean, of this invariant that we talked about, right? And then now this should here, and then now we can just say if f of best is greater than 0, is this true? And now this should be much faster because now this is O of 1, right? Well, I mean, at best it's 26 characters anyway, so it's really fast. And so yeah, let's give a quick submit. Well, all that, and I'm wrong. Oh, sad Larry. Why is that wrong? All right, let's see. Huh. All right, let's run through it. Maybe my greedy problems are kind of tricky like that. Maybe, and hopefully, I don't know. I wouldn't say hopefully it is an implementation thing, but maybe it's not. Okay. So what we do is that we go, okay, we know that there's an f. So what happens is that we go v z h o, and then we move the f's, right? Okay, the f we have here, and then now we want n from this one, right? There's an o. Okay, so what my strategy is that because what I said was that I want to always take this O, right, from the T, and then after that it goes, and then it goes PO, and then now we move for PO. So no, my algo is wrong, H. But what they actually want is in a parallel universe, we have what was it? Let's just start over. Right, so then now we right, reset, we have HO, and then now we remove the L, and then now what they want is that actually OH would be faster than better than OP. Wow, not gonna lie, this is why greedy is hard. You have to be so exhaustive about all the cases, and I was, as you saw, I was trying to be exhaustive with all the cases, but clearly I'm wrong here. But the thing with greedy is that there are still a couple of ideas, right? The idea now is going to be this exchange principle, right? Let's say we take this O. I mean, sorry, friends. I'm trying to formulate how to come up with it, and I don't know if it's like, with the tricky thing about these greedy problems is that it's not all. I'm trying to figure out for the first thing I'm trying to figure out is whether this is a quote unquote a local problem or a global problem, right? Meaning, is it like an algorithm problem that I'm just wrong in general? Maybe it's not even greedy, for example, or is it just like a minor if statement could fix it, like something that's local that maybe I just misinterpret or didn't understand, right? And yeah, and is there some exchange idea of like, okay, well, if we take this O, we can do the math of like, okay, then. But I don't not that there's something like this, but I don't know quite exactly. But here, like we would do an exchange principle on like this O would mean that we have OPO, and then this O just means that we have OH OP, kind of, right? Which is kind of a little bit awkward because I don't know that that's quite how I would put it. But then how do I know to take this O instead of, wait, no, wait. Oh, no, I think I simulated wrong. No, did I, wait, let me simulate again. Give me a second. I think I simulated wrong, and then as a result, I think the answer may be more obvious. Okay, so then now first we go to get the F, right? We take the N from the top, and then now the idea is that we take the O and then the H, right? Which is what we want to do, because we want our code set. That was my initial understanding. So I think I just have an implementation error, because now we are taking, or not an implementation error, but something that I just didn't consider, which is a good thing, because it's just a minor if statement, like we said. It's a local thing, not a global thing. Because then now, after we take the O, the thing is that I was just a little bit sloppy, because then now best is you go to A, so we still want the A, but it's not, right? Because, well, I mean, the best at this point is going to be an O, right? So after we turn an O, we go, okay, well, best, but we actually have an H. We don't need to get this O. So we kind of messed up here. So then actually here, maybe we can write, and honestly, I kind of messed up, maybe. I think if I were to do it again, maybe I should have used like a heap or something to get the min on the top. Because I think, so what I did with this best, and now that I think about it, I don't like it that much, well, mostly because it's wrong, is because I used it as almost like a pointer to the min character on top, right? But it actually maybe this is not quite the right way to do it, to keep the min character. Because then now, okay, let's rewrite this a little bit. And without the best thing, I think our idea is like 90% right, but I'm missing the case where if you remove the O, well, now you have an H. The H is lower than best, so of course you want it. Yeah, and maybe we can. I think we can maybe do an if statement here, but because the only time that state changes is if we pops one off here, right? Okay, right. So then maybe maybe we can just do something simple, actually. Maybe we don't have to be so drastic, even though I think this feels hacky now, so I don't like it. So basically we convert to either min or the last character, right? Something like that. This is, of course, if length of t is greater than 0. So now it works. Let's give a quick submit. Yeah, so that's what I mean, right? Greedy prompts could be really tricky, as you saw how I debugged this. First of all, you should simulate it, but the idea here is that the reason why I was able to come up with this fix, even though it took, like, it is 2 lines of code, but it's a very, as you saw, a couple of minutes of fix, is that's the only time the state changes for best, right? Because my invariant, which turns out to be true, which turns out to be wrong, my invariant was that, okay, best only goes incrementally one way as we go, like, okay, can we get an A, dot. But what I didn't consider is that once you pop off the T, well, now you have, like, it's almost like, I don't know, finding a caveman in an ice glacier thing, right? You uncovered some ice, and then you're like, oh, this caveman may actually be the best, so let's go back. And that's the part where I just kind of forgot, right? Because of this. Okay, so what's the worst case scenario, right? So worst case is that for each character we do for each n input character for the S, we do 26 operations, basically incrementing best every time for each character. So it's gonna be O of alpha times n in the worst case, and that's just a lazy analysis. It could be better, it could be worse, but that's just a lazy analysis. Or like it could be slightly better, but maybe not by that much, to be frank. Yeah. Yeah. I think that's all I have for this one. Yeah, I think that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. Have a great weekend, everybody. It's coming up. I'll see y'all later and take care. Bye bye.